Awesome. Right, so hello everyone. Now we will discuss about linear and polynomial regression. So for our objective for this lesson, first we will discuss the concept of regression, differentiate the linear and polynomial regression, and for your exercise, the implementation of both regression methods in our script, and also yung interpretation din ng result of these methods. Now, just a general overview, pumapasok na tayo ngayon sa concept ng curve fitting. So when we say curve fitting, we're trying to create or produce a function to represent yung relationship dun sa data points natin. Okay, so it can be done by using regression or interpolation. So sa mga susunod na labs natin, we will discuss about interpolation. Pero for this lab, tayo ay mag-regression muna. So for example, dito sa visualization, sa mga plots dito sa baba, so makikita ninyo yung we have data points here and then we are trying to fit a line. Okay, so we are trying to fit a curve. So, paano natin mapoproduce ngayon yung line or curve na ito? We will use regression. Okay, so that's the general idea. Now, when we say regression, regression is a function that generalizes the trend of your data points, but not necessarily to hit or pass yung mga points natin. Kasi yung interpolation, yun yung ginagawa niya. We want to connect the dots. Pero for regression, ang goal lang natin is makapag-produce tayo ng line or ng curve para ma-generalize natin yung pattern or yung trend ng ating data points. So actually, itong regression ay common din sa machine learning applications, especially if we want to predict an input, 'di ba? Gusto nating malaman ano yung output given this input. And then we have a set of data points. Yun yung training data points natin. Okay, so ngayon sa under regression, we have linear and polynomial regression. So tingnan muna natin si linear, yung pinakang simpleng method ng regression. So when we say linear, we try to model the relationship between the dependent and independent variable. Okay, so sabihin natin meron tayong x and y. So si x yung ating independent variable, yung ating input. And then we have y na nakadepende dun sa input natin. Okay, nakadepende dun sa x. So this relationship is represented by a straight line. So since linear regression muna tayo, straight line lang siya. So kung marirecall ninyo yung formula ng line natin, di ba? During high school, dinedefine natin yun as y is equal to mx plus b. So pwede nating isulat yun, i-rewrite natin yung equation for linear regression like this. So you have a sub 0 plus a sub 1 multiplied by a variable x plus some error term. So siguro sa lecture ninyo madi-discuss more on the theory nung nitong um, equation na to, bakit kailangan ng error term. Kasi when you plot the line, hindi siya exactly kasi magpa-pass through dun sa mga points. So na-generalize natin yung pattern ng data points, pero hindi tayo exactly dumaan dun sa mga data points. So therefore, meron tayong mga error. Okay, so mahalaga tong error na to kasi later on, meron tong derivation kapag nire-write natin kasing equation to error is equal to f of x minus a sub 0 minus a sub 1 multiplied by x. Meron na tayong function kung saan naka-equate na yung error natin. Right? So error is equal to this. Ngayon, ang magiging goal natin is to minimize the error. And yung pag-minimize ng error, usually mag-involve yan ng mga derivatives, right? Yung rate of change. So gusto kasi natin na wala nang masyadong changes. Kumbaga, fix na siya. Zero yung error natin. So kapag inequate natin yon, yung mga partial derivatives, yung rate of change to zero, makakabuo tayo ng set of linear equations. So kapag meron na tayong system of linear equation, pwede na natin siyang gamitin ng Gaussian or Gauss-Jordan para makuha yung solution set. And then yung solution set natin, yun yung magsaserve as the coefficient dito sa ating equation of the line. Okay, so that is for linear regression. Now, for polynomial regression, generalization lang naman siya. So basically, ang linear regression is similar to, ang polynomial regression, pwede din niya i-accommodate yung linear regression. So isa-set lang natin yung degree to 1. Now, for polynomial regression, again, it is a model of the relationship between the dependent and independent variable. Ngayon, by a means of a polynomial na. So, hindi na lang siya basta straight line. Pero kung isa-set natin yung degree natin to 1, so essentially, makukuha lang natin din ay linear regression. Ngayon, yung general formula niya or equation ay parang ganito. So, you have a sub 0, a sub 1, x. 'Di ba? So, kapag hanggang dito lang tayo, meron tayong linear regression. Pero let's say kapag degree 2, meron tayong plus a sub 2, x squared. Kapag degree 3, you have a sub 3, x cubed, and so on. So hanggang a sub n times x raised to n. So kung ang n, yung n natin yung degree plus some error term. Okay. So again, itong equation natin na to, ano yung ano dito? Yeah. So itong equation natin, again, meron yang may mga gagawin ba tayong mga derivation para mag-arrive tayo dun sa system of linear equation. Pero let's assume na na-derive na natin siya. Pwede nating, kung matatandaan nyo yung concept ng augmented coefficient matrix, gagamitin natin yun to get the solution doon sa set of system of linear equation natin, right? So, okay. So, let's have an example. So, for example, ang degree natin is 2. Yan. So, sabihin natin na gusto natin yung polynomial regression na i-create natin ay may degree 2. So, yung n natin dito, yung variable natin is uh, n. Yun yung gagamitin natin. Lolo ko siya. So, we have n here. 2. And then yung output function, ito kasi yung goal natin, ma-produce natin itong function na to. So, ang expect natin kapag degree 2, you have a sub 0 plus a sub 1 times x raised to 1 yan. Ito ay multiplied by x pa rin to pero raised to 0. And then finally, you have a sub 2 multiplied by x squared. And then, si d naman na variable is the number of data points. Now, kapag i-create natin yung augmented coefficient matrix, ganito yung formula natin. Okay, so anong observations natin dito? Let's see. Okay, so anong observations natin? Kung meron kang degree n is equal to 2, ang number of rows and number of columns nung mabubuo nating augmented coefficient matrix is actually n plus 1. So kung makikita nyo, you have first row, second row, and then yung third row. Okay, and then for the number of columns, meron kang n plus 1 for the coefficient matrix plus 1 pa dun sa RHS. Kaya siya n plus 2. Okay, so again, kapag ang given na degree ay, let's say, 2, n is equal to 2, yung dimension ng augmented coefficient mo ay n plus 1 by n plus 2. Okay, ano pang mga observations natin dito? Pasok tayo dito sa mga equations. Ano ba itong mga summations na to? So, meron kasi tayo, again, relationship siya ng dependent and independent variable. So, yung x natin dito is your independent variables. Now, given yung data points natin, kinukuha lang natin yung summation ng mga data points na naka-raise dun sa certain exponent. Okay, so for example, dito sa first part, you have summation ng mga x x values mo na naka-raise sa 0. So essentially 1 lang din naman 'yan. So kung ilan yung data points mo, equal lang din to sa d, right? So next we have summation of x raised to 1. So lahat ng x values i-raise mo to 1 and then kukunin mo yung summation nila lahat. Then next you have summation of x squared. So i-squared mo muna lahat ng x values and then summation nila. Pero pagdating natin sa second row, iba na ulit yung starting exponent. Okay, so dito nag-start tayo sa 0 and then 1 and then 2. Pero dito nag-start tayo sa 1 followed by 2 followed by 3. So nagta-traverse tayo per column. And then sa third row, starting sa 2, sa 3, and sa 4. So ang observation natin dito, the exponent of the first column, so ito yung first column natin. So nagsa-start siya sa row number -1. So kung nasa row 1 ka, ang starting exponent mo dito ay 0 kasi 1 minus 1. Kung sa row 2 ka naman, you have 2 minus 1, so 1. And then kapag nasa third row ka, so you have 3 minus 1, so you have 2. So sana nakikita niyo yung pattern. And then as you go along sa mga column, from that starting exponent, mag-increment ka lang lagi ng 1. So you have 0, 1, 2, dito ay 1, 2, 3, then 2, 3, 4. Okay. And then the exponent is incremented by 1. So that is for your coefficient matrix. So ito yung coefficient matrix natin na n plus 1 by n plus 1. Medyo mahirap mag-sulat sa mouse pad. Ayan. So you have n plus 1 by n plus 1. And then yung i-augment natin is the RHS. So ano naman difference nung formula nito? As you can see, may similarity dito sa part na to kasi summation of x. Pero aside from x, kailangan i-multiply mo muna siya dun sa kapartner niya na y na data point. So pairing kasi yan ng x and y. So if you have the independent variable x, meron siyang kapartner na dependent variable y. So ang gagawin lang natin dito is, punin natin yung x raised to an exponent multiplied by y and then get the summation. So dito nag-start tayo with exponent 0, you have 1, and then 2. Sige, tingnan natin sa example para malinaw. But before pala sa example, ito yung generalization nung augmented coefficient matrix natin sa polynomial regression. So as you can see, yung ating, let's say you have a degree n. So yung i-expect natin na dimension ng aug-coef natin is n plus 1 by n plus 1 kapag hanggang dito lang yung mismong coefficient matrix. Pero n plus 2 yung kabuuan kasama yung right-hand side. Okay, so yan yung generalization. Okay. Now, let's have an example. So meron tayong data points na dito. We have yung ating independent variable x and then dependent variable y. So meron tayong vector of x and vector of y. So ang gusto nating ma-produce ay polynomial regression of degree 2. So we have n is equal to 2 dito. And then take note na rin natin yung variable d. Ilan ba yung data points natin? So meron tayong 1, 2, 3, 4, 5, 6 data points. Kaya siya d is equal to 6. Now, since degree 2 ito, so kanina naman na-build na natin yung example ng aug-coef matrix kapag degree is equal to 2, right? So magiging 3 by 4 siya na aug-coef matrix. So kapag higher degree, let's say 3 by 3, so mag-extend lang to. So paano kapag degree of 3? Magkakaroon siya ng fourth row, dito magkakaroon ng fourth column, and then, yan, mag-expand lang yung ating aug-coef matrix. Okay, so paano natin sisimulan? Pwede tayong mag-start sa step 1 pwede nating, sige, breakdown natin yung large problem, ano, para ma-fill up natin yung buong OGCOF matrix. So first, pwede ka mag-declare muna ng matrix na n plus 1 by n plus 1. So mag-focus muna tayo dun sa coefficient matrix. So ito muna yung pag-focusan natin na mabuo, makuha yung values. And then step 2, kunin natin itong RHS. And then step 3, i-feed natin yung OGCOF matrix natin sa Gaussian or Gauss-Jordan algorithm na ginawa ninyo previously para makuha yung solution set. And then once na makuha natin yung solution set, we can build na itong function that represents the curve or the line. Okay. Uh, Sige. Start tayo sa step 1. Compute natin yung coefficient matrix. So, pwede ka actually mag-loop dito, no? So, ang focus natin muna is nasa row 1 tayo, column 1. So, kapag kinompute natin, sabi kasi previously, ito ay summation ng x raised to 0. So, kapag kinompute natin yon, you'll get this. And so, kunin natin per element of x. So you have 0 raised to 0 plus 1 raised to 0 and so on. So summation siya nung mga x values natin raised to 0. And then, pag kinuha natin yung summation, makukuha natin yung value na 6. So kaya papalitan natin siya ng 6. Okay, so next, lipat tayo sa column number 2. So, summation ng x raised to 1. So, kapag in-expand natin, ito yung makukuha nating um, value. So, we have 15. Okay? And then, last column for row 1. So, column 3 na tayo. So, lahat naman ng summation ng x squared. So, kapag in-square natin, and then get the summation, you'll get 55. Okay. So, ngayon, meron na tayong values nung first row. So, punta naman tayo sa second row. Second row natin ay summation of x raised to 1. Okay, so, na-compute na natin to earlier. So, makukuha natin yung 15. Then proceed tayo sa next column. Summation ng x squared, you'll get 55. Then summation ng x cubed, you'll get 225. So, tapos na tayo sa second row. Last row na tayo, row 3. Again, column 1 ulit. So kapag tinuloy niyo yung sequence ng ating computation, so di ba kukunin niyo yung row 3, column 1, row 3, column 2, and row 3, column 3. And then, ito yung makukuha nating answer. Iyan. So you'll get 6, 15, 55, 15, 55, 225, and 55, 255, and 979. Yan. I think 225 dapat ito instead of 255. Okay, so tapos na tayo sa computation ng coefficient matrix. So ang second step natin is to compute for the RHS. So let's see. Paano naman tong RHS? So for example, dun sa ating row 1, column n plus 2 is equal to 4. Well, actually, pag i-code nyo siya sa R, pwedeng hiwalay muna yung coefficient matrix doon sa RHS. And then later on, kapag okay na yung coefficient matrix, tsaka yung RHS nyo na vector, pwede nyo silang i-columbine later para maging buo na yung augmented coefficient matrix. Okay, so again, going back dito, so summation siya ng mga x natin raised to 0 multiplied by y. So for example, you have your x0 raised to 0 multiplied by, so dito sa table natin, yung kapartner niya na y is 2.1. Then you have 1 raised to 0 multiplied by dun sa kapartner niya na y, which is 7.7, and so on. So summation siya ng product. And then yung answer natin na makukuha kapag in-evaluate ito ay 152.6. So, i-replace na natin yun. So, tutuloy nyo lang yan for the next two terms. yung mga summation natin. So, ang kasunod niyan is this one. Kapag in-evaluate natin, you'll get 585.6. And finally, summation ng x squared multiplied by y, you'll get 2,488.8. So, here's our final um, matrix, no, augmented coefficient matrix. So again, I think may correction dito. This should be 2, 225. Yan. Okay. So, anong next natin? After makuha yung augmented coefficient matrix. Ngayon, ito yung gagamitin natin for step 3. If-feed natin siya dun sa function na na-create nyo na Gaussian or Gauss-Jordan. So, pwede kayong pumili lang ng isa kung anong working. So kapag finid natin si OGCOF matrix kay Gauss-Jordan, for example, ito yung makukuha nating solution set. Okay, so ito yung solution for our unknown values. Yung coefficient natin na gagamitin dun sa line or dun sa equation. Okay, and then step 4, i-build na natin yung f of x. So as you can recall, 'di ba, ito yung gusto nating ma-achieve na f of x. So paano natin nasabi na ganito? Kasi yung degree natin is 2. So a sub 2, x2 yung last term. And then ito yung mga for x raised to 1, ito yung for x raised to 0. So kung i-rewrite natin, parang ganito siya. Okay? So kapag higher degree, dadagdagan lang yan dito. Yan, something something. Okay, so yung first solution natin dun sa set, yun yung ating a sub 0. Ito naman for a sub 1. And then finally, ito yung for a sub 2. Okay. Yan, so yan na yung function natin. To generalize yung given natin na example, yung table natin ng x and y. Yan. Now, for example, paano naman natin to interpret? Paano natin gagamitin? So, given yung function natin na na-build, yung f of x, for example, ito yung mga given natin, iba na x input, 0 to 5. Paano kapag gusto kong malaman yung y value kung yung x natin ay 2.5? So, dito kasi, hindi existing yung 2.5 na input. Pero gusto kong malaman ano yung value ni y kapag 2.5 yung input. So, we can use this f of x na na-build natin from this table, right, na nag-generalize nitong data points na to. So, kapag pinlog in natin si 2.5, makukuha natin si 20.00625. So, tingnan natin visually. Yan. So, makikita nyo na kapag pinlot natin si 2.5, yung x, yung y na makukuha niya based dun sa blue line. So, yung blue line natin is the f of x. Right? So, yung f of x na na-create natin. So, ito yung f of x, yung kulay blue na line. Makukuha natin yung 20.00625 something. Yan. So, na-approximate natin yung or quote-unquote na-predict natin yung y value given lang yung input x value based doon sa natutunan nating pattern ng mga data points na given. Okay. So, I think yun na yung end ng presentation. So, for now, ay punta naman tayo sa mga tips and essentials no dun sa exercise ninyo. Okay, so dito naman tayo sa coding part. Ano yung mga helpful or makakatulong sa gagawin yung exer later on? So una, obviously magke-create kayo ng matrix. So kung hindi pa kayo familiar sa pag-create ng matrix, again, review na lang to. We use the matrix function. Pero paano kapag gusto niyo mag-create ng empty matrix? Pwede tayong mag-create ng empty matrix. Hindi lang kayo magsusupply ng value for the data. Pero isa-set niyo yung n column. So, n column and n row. So, important na specify niyo yung label. Kasi kapag wala, i-assume niya lagi yung first instance ay yung data mo. So, n row is equal to, for example, 3 by 3 yung gusto natin gawin. Equal to 3. So, print natin si M. Yan. So, ito yung magiging resulting matrix. Puro NA siya kasi wala tayong pinasang data. Pero kung nabobother kayo, pwede nyo lagyan ng 0. So, i-repeat lang niya yung value na 0 dun sa empty matrix. Okay. Aside from empty matrix, important or helpful din yung cbind, column bind. Meron ding option na row bind. So, ang ginagawa ni row bind, ididikit niya yung vector or matrix dun sa row na axis. Pero pag column bind naman, sa column niya, sa column yung pag-combine niya. Okay, so for example, gusto kong combine ng cbind yung ating function for column bind. So, let's say, si matrix, gusto kong dagdagan ng RHS. So, gawa na lang ako ng 1, 2, 3 na vector. Print natin si combine. Then, ayan. So, nakita nyo, ito yung original matrix natin. And then, column-wise, nag-bind tayo ng vector na 1, 2, 3. So, pwede rin mag-bind ng matrix to matrix. So, yung C-bind or R-bind, pag R-bind kasi ay row naman. So, sa row siya na-append. Okay. Next is yung string concatenation. So, makakatulong din tong string concatenation. So, ang ginagamit nating function to concatenate strings ay yung paste. So, for example, gusto nating i-concatenate si A tsaka si B, si hello world. So, i-list lang natin dito kung, let's say, meron ka pang ibang gustong i-concatenate. So, ililist lang natin siya separated by comma. And then sa dulo, pwede nating i-declare yung separator na attribute. So, when we say separator, ano yung gusto nating magsa-separate dun sa i-concatenate natin na string. So, for example, plus, print natin si C. So, you'll get this. So, hello plus world plus what. Okay. Yan. And then, what else? Next is yung eval parse, string to function. So, important din to. Kapag gusto mo mag-convert ng string and then gusto mo siyang gawing function. So, for example, str function. So, tanda pa ba kung paano mag-declare ng function? Pwede tayo mag-declare ng function na one-liner. Let's say 3x. 3 multiplied by x. So, anything na ipapasa nating x value will be multiplied to 3. Ayan. Pero kunwari, siya, string. Okay, so obviously, hindi natin ito magagamit as a function kasi string siya in the first place. But we can use the eval parse. So, evaluate. But before evaluating it, ipaparse muna natin. And then, meron itong attribute na text. And then, ipapasa natin dito yung string. So, again, text is equal to yung string na gusto nating i-evaluate. So, pag pinrint natin to, makakakuha ka ng yan. So, na-print na yung function. Try natin gamitin. So, let's say answer is function and then pasa tayo ng 3 times 2. So, 2 yung x. Print answer. So, dapat makukuha ka ng 6. Right? Kasi nangyari, nagpasa tayo ng value na 2, and then, na-multiply siya dun sa ginagawa ni function is na-multiply to 3. Okay, so, working na yung ating function. Di ba from string, naging working siya na function. Okay. Next is plotting. I think last na to. Last example. Paano naman tayo magpa-plot? Although hindi to required sa exercise, pero very helpful to para ma-visualize ninyo yung na-create na function. Okay, so let's declare muna yung x and y. So this is your independent and dependent variables. Then you have your model. Now, itong LM na to ay built-in function na mag-create ng mag-implement ng polynomial regression. Although hindi nyo to pwedeng gamitin for your exercise kasi ito na yung built-in function. Pero you can use this to check yung output ng makikreate nyo na function for polynomial regression. Okay, so anong syntax nito? You have LM for the linear model. And then yung formula. So for the formula, you have your dependent variable muna, y. Tapos gamit ka ng, I forgot kung anong symbol to, tilde yata. Tilde. And then meron tayong poly function. So kapag wala kasi si poly function, like ganyan lang siya, by default ay linear regression yung i-implement niya. So gagamit tayo ng poly to indicate na polynomial regression yung gusto natin gawin. Pero you can set this to 1 para maging linear regression. Okay, so inside ng polynomial poly function, meron ditong x. So this is your independent variable, followed by the degree. So anong degree yung ipapasa natin. And then ilagay nyo lang dito na yung row natin ay true. So meron kasing explanation if you look here sa help poly function. Yun. True, if true, use raw and not orthogonal polynomial. So, we don't care naman about orthogonal polynomials. Isa-set natin to 2. And then finally, after this formula, you have your data. Although, ang ginagawa kasi ni LM, nag-accept siya ng data na data frame. Kaya isa-set lang natin to a data frame itong X and Y natin. So, if you can remember or recall, yung data frame ay isa sa mga are objects, right? Kasamahan ng matrix, ng vector, ng list, etc. Okay, so when we print the model, yan. So ito yung na-create na model. Yung built-in, using the built-in function LM. So as you can see, nandito yung coefficients. So ibibigay niya yung coefficients nung function or nung line na na-create kapag degree is equal to 3. Okay, so kapag mag-check kayo if tama ba yung output ng polynomial regression, yung kanyang coefficients, ito yung i-check ninyo. So, meron ka ditong 4. So, bakit 4 yung um, coefficients? So, ang formula natin pag yung number of coefficients ay n plus 1. So, kung ang degree mo ay 3, ang i-expect mo na number of coefficients ay 4. So, n plus 1. Okay, so nag-create pa lang tayo ng function. Try nating i-plot. So, yung pagpa-plot natin is using the built-in function plot. So, ano yung arguments nito? Pwede nyong puntahan dito sa help function and then plot. So, makikita nyo dito yung detailed na, where is it? Mukhang ano, marami pa palang options. Pero yung arguments natin for plot, so you have your x and y, kung ano yung points natin, yung dependent and independent variables. Yung type is kung anong type ng point yung ipa-plot. So kapag P ay point, and then pwede rin yatang ibang, pwede nyo explore yung ibang variation kapag gusto nyo na asterisk or plus or triangle. So pwede nyo i-modify yan using this. Yung PCH naman is yung size ng point dun sa plot. Call ay yung color ng point. And then itong main naman is yung main title ng plot ninyo. X lab is for yung x-axis label, and then y lab naman is for y-axis label. Okay, so try muna natin yung plot. Okay, try natin tong plot. Yan, so lalabas siya dito sa um, lower right, no, yung plot na natin. So essentially, pinlot lang natin yung given na x and y. So color red na point. And then, we can use lines para ma-plot natin yung model na na-create using LM. Okay. So yan. So nakita ninyo, ang argument natin for lines, you have your x, and then yung y niya is yung prediction ng model. Okay, so yan. So ang in-input natin, essentially ini-input lang natin every x dun sa prediction. So makukuha natin tong line na to. Color green. Okay, so we use this lines kapag ipapulat natin yung LM na built-in function. Ngayon, um, paano kapag gusto mo namang i-plot yung sarili mong function? So for example, let's have this f of x na to. So function x, and then we have this. Okay. Paano pag gusto ko siyang i-plot? I can use this built-in function curve. Yan, curve. So yung curve natin, yung first argument niya is your function. And then yung call naman ay color, and then yung add is if you want to add it dun sa existing plot. So ito true natin yan. So when we run this, yan. So yung color blue na yan is your curve. So let's say baguhin natin to, gawin natin 5. So nagbago na yung itsura ng curve natin. Okay, so ano ko din to, add ko na yung lines. Yeah, so if you want to make comparison, so yung lines is ginagamit again for LM, built-in function. And then yung curve naman, ginagamit ko siya for my own function. Ayan. So if you want to compare yung your own function na na-generate versus dun sa na-generate nung LM. Okay. Ano pa ba yung exercise? Right, so that's it. Yun yung ating discussion on linear and polynomial regression. So if you have any questions, feel free to reach out via email. So stay safe, everyone.